Okay, so now let me tell you, if there's no invariance, let me ask you this. Okay, what about sorry, that's not a good example. What about June 31? Okay, June. Actually, to be, so when I say June, I really meant month to be 6, right? I'll just put a 6 over here, right? What if the combination of 6 and 31? Well, 6 is between 1 and 12. 31 is also between 1 and 31. So now we are missing something in the invariance. So that means our invariance is too weak. It allows certain invalid combination of the month and day. So we want to fix that. But how do we fix it, right? Well, a very naive way would be something like this. I'll give you one idea. Okay, something like this. It can be valid combination of month and day. I'll give you one trial. Okay, so I'm going to be a little bit lazy here. I'm just going to copy some text from my notes over here. So how about this? Let's say if the month here, so here it should be just month, right? Let's just sketch the idea to you. So just pretend M is actually month. If month is either January, March, May, July, August, October, or December. If either of them is actually true, bracketing using parentheses, and then that implies the day should be equal to 31. Oh, so not equal to 31. It should be between. It can be maximum 31. Okay, it should be 1 less than or equal to day, and day less than or equal to 31. But it's actually quite tedious to actually type this out, and it's not very reusable. It might be that it's very often that we have to check for this condition here to see, given a particular month value between 1 and 12, we want to know if that particular month has up to 31 days. And maybe for other months it's up to 30 days. And for February, it's only up to 29 days. Let's not worry about leap year in this particular tutorial. Okay, so now I'm going to use this opportunity here to say this will definitely be correct, but it may not be so reusable. So I would like to show you some nice feature over here. One way to do it is use something similar to a static accessor in Java. So we're going to do a static query in IFO, right? So now I'm already using terminology. So I should really define a query that's going to return back to me whether a particular month should really have 31 days or has 30 days. Okay, let me do that quickly here. So now under queries over here, I'm going to define, first of all, I'm going to start with is month with 31 days. And then there will be another one is month with 30 days in a very similar way. But let me do this one first, and then the other one can almost be copy and paste. So now for the month over here, mem should be integer, okay? And then it should be a Boolean over here. Okay, return a Boolean. Given an integer, it's going to tell me true if it's with 31 days, false if does not have 31 days. Okay. Okay, so now every time when you program a class, you want to always think about class invariance. Now when you program a feature, when you program a routine, either query or a command, you should always think about precondition and postcondition. Think about, okay? So now precondition, as you either have or you will study the lecture notes for week number 1, precondition is really about valid input condition. Under what circumstance should its month with 31 days serve? So now I would say require over here. The require is the keyword. Under require, you can specify as many Boolean conditions as you like. And just as the class invariance, every precondition should be tagged for traceability. And then I'll later on show you how useful a tag could be. You can also use that to write good test cases. Okay. So now require, I'm going to have valid month over here. And then first of all, you want to make sure it's a valid month value you're giving here, right? Less than or equal to n, and n is also less than or equal to 12. Do over here, okay? So do and end, usually within this, that should be the implementation, okay? But now I'm going to do post condition first. And the post condition is going to be anything that's under this particular ensure clause over here. So this will be the post condition. Just for this one here, I'm going to annotate for you. So this will be the precondition and the ensure will be the post condition. So rather than thinking about implementation first, I'm going to think about post condition first. So post condition is like in the case of a query, over here, the way to think about it is what's the relationship between the return value and the input. Okay, so that's something I'll write down here. And also, you should really put the comments over here. I'll put the comments here. Okay, so that should be 3 indents. 1, 2, 3. Right? Just follow convention. Also, it looks nice. And also, when you do documentation, if you want to mention the name of the parameter over here, you will use backrows over here, 2 backrows over here, and then put an n. So it will appear a slightly differently in the iFlow Studio. So easier for me to spot. It's actually a parameter. Is n a month with 31 days? Okay, that's the comments for this particular query. And now I just want to put a little bit comments over here for you. For precondition, it's basically the valid input condition constraint. Okay. On the other hand, for post condition over here, in the case of a query, it's going to be the relationship between inputs and outputs. Output is like a return value, and inputs are the parameters over here. So what's the relationship between them, right? It's going to be very similar to what I just wrote over there as a first try over here. Okay, let me just copy that. Oh, just up to here. Okay, this guy over here is going to be a Boolean. I'm going to say if, so m is either at 1 or 3 or 5 or 7 or 8 or 10 or 12, right? So now this will be equal to, if this is the case, right? Well, let me just tell you directly what the answer is, but think about it mathematically. So now how do you, oh, there's one thing I forgot to mention, right? In logic, you got another operator, okay, which is if and only if. Okay, if and only if, in our case, it would just be equality. So equality would just be equal sign in iFlow. In Java, is actually double equal over here. Okay, let me just mention one more thing since I'm already here. When you do assignments in iFlow, when they do assignments, variable assignments, they actually use colon equal. Okay. On the other hand, in Java, how do you do assignments? You actually just use equal over here, right? So they are very different. Whereas in iFlow, when you do equality comparison, they simply just use this mathematical symbol, just equal sign. Whereas Java use equal. Again, it's a language design choice. But I would say, I'll tend to argue, in the case of iFlow, imagine if somebody knows nothing about programming. When they first equal sign, would they tend to think it actually means something that's going to change something else, or is simply mathematical equality? I think mathematical equality should be the case for somebody who has no prior programming experience. So I would say it's a language choice, but I think it's a convincing one. Okay, it's a very quick comparison for you. So now if I go back here, so there's going to be either this month can be either of these values over here. So that would be if and only if. Okay, you can say result, which is a Boolean value over here. You can say result is equal to true. That's one way to think of it, but I would say that's a bit too wordy. Why don't we say if and only if result? Okay, you can think about it in the following way. It's that because that's if and only if, so we can interpret in two ways. When m is either of this value over here, that implies result is actually true. And when result is actually true, that implies m is either of these values. Okay, that's if and only if. Okay, study this a little bit. If you got questions, please get to me. And then I better put some tag over here just to say what this post condition is, right? So now I can say correct result, right? Just correct return value. Okay. Okay, so let me just make sure everything still compiles. Okay, and then what I will do now is let's figure out the implementation. How do I do the implementation? I would say the implementation for this simple case over here, I would say you definitely have one very simple one. Let me just show it to you. alternative number 1 for implementation. And notice that in this case, implementation will be whatever that's between do and ensure, okay, because we got a post condition. This guy over here is basically going to determine what the result value should be. So why don't we say result over here? Remember I said before, for any query, we don't have the return statements like accessors in Java. There's no return statements in iPhone. What you got to do instead is to imagine the last line of a query is to say implicitly return result. Okay, just imagine that, right? And now we just want to make sure the last reassigned value for result is really the correct value. So now we want to say result is assigned to this particular expression. Okay, so you can see now in this case the implementation and also the post condition here is almost the same, but that's okay. It's a very simple query, so in this case you cannot really see the advantage of having some elegance post condition, but that's okay. But I'm gonna suggest another alternative to you. So this one works. I'll put it in comments. Oh, how do I put in comments? I forgot to mention. In order to put a block of code into comments, you're gonna say you should say Control K. Okay, Control K will actually put a line into comments. Shift Control K is going to remove the comments. Okay, again Control K is going to put it into comments, and then Control Shift K is going to remove the comments. Okay, just make sure you understand that. Okay, so now what would be alternative number 2? So alternative number 2, I can also show you some other constructs. For alternative number 2, I'm going to use some local variable. Okay, so now where should I put a local variable? So now this is a precondition here. Think about preconditions like something we publish to the public to say, in order to use this particular feature, you must satisfy this particular precondition. And we said that's the obligation for clients. So make sure you study lecture number 1 for week number 1 so you will understand what I'm talking about. Okay, so now we want to say as part of the implementation, we're going to declare local variable. That's why local should really happen after require. Okay, that's a common mistake. Students sometimes put local before the require. That doesn't make logical sense. Local and do is part of the implementation, so that they should come together. So now for local here, we're going to do some array, let's say commands over here. So how do you declare array? Okay, it's going to be of type array. Array is a class name, and then square brackets, and then you want to say what's the type of the array, and then you would say integer over here. Okay. Later on, we talk about iPhone collection classes are generic. So we talk about genericity a little bit later in the lecture, but now we're just saying every member of the array is simply integer. Okay. And now how do we initialize an array? In Java, to initialize it directly, you would say the curly brackets notation, but in iPhone, it's slightly different. Okay. So we're going to say, let's say months is simply assigned to, you're going to say 2 angle brackets, right? Of it, and also make it a pair both ways. Okay, and then we're gonna say, let's say for those months that should have 31 days, 1, 3, 5, 7, 8, 10, and 12. So this is basically the months over here, and then we want to say result should be equal to, result should be true if the input m is actually in this particular array. So now we want to know what's the contains method of the array, right? So let me show you very quickly. If you go to the array class over here, as we said before, let me just show you the feature for array. For array, let me just compile. Okay. So for array, one of the feature you can use is called has over here. Okay, has is going to check the membership in the array. So there are other features which I will show you a little bit later in a separate video for array and linked list. These are the common ones. Okay, let me go back here. So what I can say is result is simply assigned to some Boolean expression. I can say months dot has. Okay, and then has will be what should it be? Just m, right? So we're saying that m should be a member of the months over here. Okay, and then let's compile. So everything compiles. So now we got a fully working is month with 31 days. And now there's another thing I want to talk about is something called test-driven developments. Let's first explain test-driven development or TDD on my iPad, and then we'll see how we can put that into practice. Okay, so now let's explain this quickly. So this is your first time. Actually, this may not be your first time seeing it. So when you learn about JUnits, it's really unit testing. So test-driven development should still be applicable over there. But let me talk about it just from scratch quickly. It's a very practical yet simple idea. So test-driven development, or TDD. So what's the essence for test-driven development? I would say there are two guiding principles for this. Number one, you should really write a test as soon as your feature becomes executable. So executable is really the key. So what does it really mean to be executable? Which means you can call a query or call a command. For example, for our case, you can see over here, is month with 31 days is a query that has an implementation. It also has the complete pre and post condition. Okay, but sometimes it may not be so complete. As soon as you have the implementation or some partial precondition, some partial post condition, you can already start writing tests just to get some idea how correct it is, and then you can work towards perfection later. Okay, so now we say as soon as it is executable, you should write a test for that, which we'll do in just a moment. And then the second guiding principle is also very important, is something called regression. Okay, so over here we run all the tests when a change is actually made. So this is something called regression, which means something you want to do over and over again. Okay, let me just see the let me just show you the flow chart over here quickly, just to see the idea. Okay, let's say we start with some info classes over here. It could be account, it could be bank, it could be anything, right? For example, let's say birthday. Okay, and then based on the feature or query or commands or attributes over there, we can derive some test cases. For example, we can test the account, test the bank, test the birthday, and then we can also we can try to run the ESpec like a EECS test framework in JavaScript. It will be JUnits. So simply run that as the test suite, so we can have as many test classes as we like, and then we're gonna run it. If all the tests actually pass, we're going to get a green bar. Then we are fine. That means as far as the current tests are concerned, we are fine. If we have any failure over there, that means we get a red bar. In that case, you should stop your current developments and then try to fix it before you move on. So that's why number 2 here for regression is really important. So the idea about regression testing goes like this. You have a set of test cases you have already developed. They somehow define the correctness of your software so far. And then let's say you try to make a small change to some feature, or just fix a bug, or maybe improve something by refactoring. If you make a change, but suddenly, rather than having a green bar, you just get a red bar. So what can be the cause of the problem? Well, maybe the small change you just did. So that's why regression testing is very valuable, given that your set of test cases actually has a large number. In that case, every time you make a change, it will be if you still pass all the test cases with the new change, so that means you should have enough confidence about the correctness of that new change. Okay, that's conceptually what test-driven development is about, which means keep writing tests and also as early as possible. You don't just write the test cases to make your professor happy. That's not the way to go, right? You write test cases because you want to be responsible for your code correctness. So write tests early and also often. Okay. Yeah, so the timing and also frequency for the test case will be very important. That's about test-driven developments here. So now let me practice that together with you. So how can we write a test case for this particular query? The way to write it is we want to go to a test class. So we already have one test class that's generated from before, but let's now rename it. Okay, the way to rename it is the easiest way to go. Simply left-click on this, so it's highlighted. And then go to refactor over here, and then you say rename. We're going to rename this particular class. So rather than test example, we want to test for birthday. And then we say OK. Okay, it's just renaming, so everything's okay. For the author, you can definitely change it. It's going to be whatever your name is. How about with me together? So we're developing together. Okay, so now let me go back to the birthday class. There's one more thing I want to add, because I want to make the query static, just to show you how you can do static features in iPhone. So now there's one more post condition I want to add. So this might look a little bit peculiar, but that's just the way to go. Okay, if I want to say in order to call is month with 31 days, if it's the normal non-static feature, in that case I have to create a context object in order to call this feature. But now if I want to say I just want to use the class name in order to call the feature, in that case in Java you will simply declare a method to be static. In IFO you will put in the post condition the following keyword, class. So that means we're declaring in the post condition saying this query is class how about belongs to the class? How about that? Or it's at the class level, which means you can only just use a class name to call them. Okay, so now you can think about it's more or less the same as static. Okay, that's hopefully that can connect to some concept you learned before. That's how you do static queries. So now let's see how we can test it very quickly. So now to test the birthday over here, we already got our cheating case over here that always passes, but let's just leave that there. That's fine. Okay, so now we can say we want to say T. Okay, so how about static query, and then I want to say it's going to be Boolean. So think about whenever you want to test a particular query or command or any feature, and it's a normal scenario. Basically, you have some expected output, and then you want to call the command or query to see if the actual output matches the expected output. In that case, you want to do just a Boolean case over here. If anytime you want to test if a particular precondition or postcondition will actually be violated as expected, that's going to be another category of test cases, which we will cover later. Okay, it's a Boolean test case. And notice that for Boolean test case, for the query you're defining over here, you don't put any parameters. That's why you don't see empty pair of parentheses, right? We already explained that. Okay, so what we will do is, so first of all, you're going to say do, and then you must put a comment call over here, right? Okay, you can use the control space to complete the call over here. So now always put a string quote and then put the name of the query first. You gotta spell verbatim, static query. Okay, so now you can say test. Okay, let me be a little bit lazy here. Let me just open another tab. Okay, so I don't lose it. So birthday, and then I will go to is month with 31 days, and then I'll copy that query name, and then I will come back here. So I'll just say test for this particular feature, this query. Okay, how do we do that? It's very easy. Remember I said it's static. So that means we don't even have to declare a local variable called birthday over here. We don't have to. Okay, so that's our very first test. Let's just make it very easy. So the way to call the a static query in IFO is very similar to how you would do it in IFO. The only in Java, the only difference is you have to brackets the class name into curly brackets. So now there will be birthday. Okay, it's a existing class, and then outside the curly bracket, simply click type dot, and then it tells you at the class level this is the static query you have available. Okay, let's click on that. So that's going to be is month with 31 days. Let's simply try a simple one. So now if I say January should have 31 days, right? So now that's already so. The rule for Boolean test case would be as long as, oh, I forgot one thing. Because this is a test query, which means it has a result, like a return value of Boolean value. So I should really reassign that. I should say result is assigned to. So now, what does it really mean for test to pass? Okay, I'll write it here. For a Boolean test query to pass. Okay, number one, no exceptions or no violation from anywhere. And number two, the last reassigned value of result must be true. Okay, it's like a return value is true. Okay, I'm just writing down. So that's a principle. These are the two principles applied to every Boolean test query you're gonna write later. Okay, I'm just write it in just one time. Okay. So now this should be returning true, okay? And then I'm just gonna write, I'm gonna say run over here, run workbench system. Remember we said, oh, before I do that, okay, it's very easy to forget. So this is only to define the test query over here. Let me show you exactly why this is wrong. If I just say run and then run workbench system, if I say that, you can see the browser over here, you can see it still shows only the original cheating test that we had. It doesn't really include this particular one that we just added. It's because we have not added the test case over here. That's the reason. Okay, so now let me go back here, and then I'll say simply say add Boolean case, add control space, add Boolean case, and remember to use agents. It's like a pointer to function. Agents t static query, and then I'll say compile. Okay, so now if I try to run and then run workbench system and it works, okay, I will leave it to you to also try. Let me just since I'm already talking about this, so I'll just mention one more thing to you. Okay, so now I want to do another one over here. Let's say I want to Control Z to undo. I want to test another value over here to make sure it returns false. For example, I can say result is assigned to, let's say, let me just copy this guy here. Okay, I'm calling the static method. So what should be returning false? How about April? Okay, what if I do this? Think about what's going to happen here. So that means this particular reassignment is going to reassign result to be true, because January has 31 days. And this one here is going to reassign the result to be false because April has only 30 days, right? So now in this case, if I compile and then run the workbench system, what I will see is I'm going to have a false. I'm going to have a failure, basically, right? It's failure because it's the last reassigned value for result is actually false. But that's not something we are expecting to see, right? We want to say result should be result over here should be about whether or not the return value is actually correct. So what do we expect to see? We expect to see, well, let me just lead you to the correct answer. You can say I'm expecting this to be false. So this will compile. We're saying this particular return value over here should be equal to false. Okay, that's one way to do it. Or you can say, alternatively, you can say result is not the case, right? You're saying result, whether or not the query is actually correct depends on whether this particular return value is actually false. So not false is going to be true. Okay, it's gonna still assign true to result. Okay, hopefully it's not really too tricky for you. Okay, I'll leave this version over here, and then if I say compile over here, and then I'm going to say run workbench system. Okay, but that's not the main points I would like to illustrate to you. I want to illustrate another points to you. Okay, which is about there is a general problem if you try to reassign the result for 2 times consecutively without an explicit assertion. That's something I would like to explain to you.